These were ones like we did on Friday. 3 interior angles of a triangle will add up to 180. So we're going to write that equation. 2x plus 2, this angle, plus 2x plus 2. Oh, those angles are the same. So what kind of triangle do we have here? An isosceles. They also have the sides marked the same. So the 3 angles are going to add up to 180 degrees. Okay? We can do that? And then I know, you're saying, oh, 2x and 2x and 3x all go together to give me 7x. And 2 and 2 and 1 go together to give me 5. And that equals 180. And then we can subtract 5. And divide by our 7. So we get x equals 25. Now, pay attention to the question, because sometimes they just say, hey, what's x? Sometimes they may say, tell me if this is an obtuse, a right, or an acute angle triangle, right? So we would have to take the 25 and plug it in to each angle to find that out. I can already tell it's isosceles by the sides marked. Okay, but here it just said solve for x. Over here, we have an exterior angle. This exterior angle is equal to the 2 angles inside added up. To take the angles that it does not touch. So they had this angle marked somehow. You wouldn't do that. 2x minus x gives me a 1x on the right. And subtract our 1x. And I know you guys can solve the equations. My main focus is, can you set the equation up? Do you know which one it is? Are we adding all the angles together to make it equal 180? Or are we taking the exterior and equaling it to the 2 other angles added together? Okay? So you have to know what equation to set up. And I should see equations on your work page, right? Not just answers. We good? Today we're going to talk about congruent triangles and what it means to be a congruent triangle or congruent figure for that matter. Basically, if you are a congruent figure, corresponding parts are congruent. Your corresponding angles are all congruent. Your corresponding sides are congruent. You can pair them all up. Okay? So, these are congruent figures. They're exactly the same size and shape. They may be rotated or reflected from one another, but they're the same size. You could overlay them and rotate them so they're exactly the same. All right? We're going to be real specific here. Here's 2 triangles. And you can see by the markings that angle A is congruent on that triangle to angle D on this triangle. They're color-coded, and they've got the little markings and everything. They're not always color-coded, obviously, but you can see the color coding. So triangle ABC is congruent to triangle DEF. And really, we don't even have to have, I could take away this picture in a heartbeat. Let's do that. Boom, boom. I should still be able to write all the congruent statements based on where the letters are in the statement. So angle A, this first letter, should correspond to angle D, and B corresponds to angle E, and C corresponds to angle F. Not just because they're colored the same, but because of the location. Does that make sense? So AB should correspond to side what? AB corresponds to DE, and AC corresponds to EF, and BC corresponds to EF, just based on the location of the letters. So the congruent statement is very important because it's showing you the congruent parts in order. All right? So we should all be able to write these congruent statements just from the name. You can do that? Whether we have a picture or not. Sometimes the pictures are more confusing, because if you take this picture away, You know, this has been rotated and flipped around. And if it wasn't color-coded, sometimes it's more confusing to go by the picture. Okay? We want you to be able to see. Okay? All right. So, write a congruent statement. I'm going to start it. I'm going to start over here and say this triangle PQR is congruent to, very specific. The order is very important. The order is very important. Hope. Very good. L corresponds to P, J corresponds to Q, and K corresponds to R. Very important. You look at how they're marked. They're not always alphabetical order. Okay? And that's okay. We good? We're set. All right. Let me ask you this. If I said the measurement of angle A, equals 50 degrees, what can you conclude there?
Angle M is 50.
Very good. Angle M is also 50 degrees. Right? If I said the measurement of angle O equals 60 degrees, what else can you conclude from that statement, Michaela? Very good. Angle C also equals 60 degrees. Given that information, can you tell me what angle B equals? What is the measurement of angle B equal? Nick?
70 degrees.
70 degrees. Remember, how many degrees do we have in a triangle? 180. We have these two angles adding up to 110. So we have 70 more degrees. For angle B and angle N, right? They're both equal to 70 degrees. Okay? So they might give you statements on measurements given a congruent statement. If I said side BC equals 10 centimeters, whatever, what other side would equal 10? NO. If I said AC, Andy, equaled 7, what other side equals 7?
MO.
Very good, MO. Everyone understand what we're doing? We are just picking out the corresponding parts. The corresponding parts are congruent, so their measurements are equal. Okay? Make sense? All good. We're rock stars. Okay. So let's look at this one. These are quadrilaterals. Doesn't matter. Same rules apply. We have DEFG being congruent to SPQR. And we want to figure out, bless you, we want to figure out the value of x. So if you look in the bottom figure, you've got a side that has an x in it, and you have an angle that has an x in it. Let's start with this. Bless you. This angle has 6y plus x. So we have an x and a y mixed. We aren't going to be able to use that right now. Okay? But the side QR is 2x minus 4. What other side from the other figure is equal in length? GF. So we're just looking here. QR is congruent to FG, or GF. Okay? So we can set those two measurements equal. So 2x minus 4 equals 12. So 2x is going to equal 16, and x is going to equal 8. Spectacular. I'm going to go back to this angle now. I'm going to change that x out and substitute it with an 8. Now I can use it. Going back, angle Q corresponds to angle, what? F. Okay, so Q and F correspond. So we're going to set 6y plus 8 equal to 68. Corresponding parts. There's a bunch of information here in this triangle, or I'm sorry, this quadrilateral that's marked that we don't need. You have to pick the corresponding parts and forget the rest of it. Okay? Make sense? We can do it. All right. Sounds smarty. Common sense theorem, third angle theorem. Basically says if two angles of one triangle are congruent to two angles of another triangle, then third angles must be congruent. That makes sense. Right? They have to add up to 180. If they're the same angles, then they're going to add up to 180 again, and the last third angle is going to be the same for both triangles. So A plus B plus C equals 180. D plus E plus F equals 180. Since they both equal 180, you can set the sides equal each other. And we can replace, so then we have A plus B plus C equals D plus E plus F. Since A is congruent to D and B is congruent to E, I can replace those. And then I can cancel them out on both sides, so E is equal to F, so they're congruent. It's just a very short, informal proof explaining it, okay? But it's very easy to look at it. It's common sense. But it's a theorem, which means we can use it in a proof, right? So we want to kind of keep that in the back of my mind. I've got two angles given to me. I automatically know the third is congruent. Okay? So, let's use that. This is so hard to see. We have triangle A, C, D. And they tell me this angle is 45 and this angle is 30. So everyone see I just took this triangle and separated it? What would this big angle be? 75? 180 minus 75 would leave me with 105. Everyone understand how I got 105 for that big angle? So in this other triangle that's here, that's a reflection of this guy, this angle is the same, and these two pink ones are the same, so aren't the two big ones going to be the same? So angle BDC is also going to be 105. First two angles were congruent, so that third one has to be congruent. So I can find it in this triangle and label it in the other triangle. Make sense? Okay, we're going to prove, I know you're very excited about the proof. We are going to prove this guy. And this is actually a very, very, very easy proof. Looks crazy because that diagram is crazy, but it's pretty easy. So they tell us that AD, side AD is congruent to side CB, and side DC is congruent to side BA, and you can see those are marked on the diagram. And they also tell us angle ACD is congruent to angle CAB, and angle CAD is congruent to angle ACB. Why am I having to use three-letter angle names instead of just saying angle C or angle A? Do you see in this triangle, this is angle A and this is angle A? Two different triangles, so you have to name them with those three letters. If not, crazy things are going to happen. All right, so this is all of our given. All of this stuff is given. Okay? Now, in order to prove two triangles are congruent, you have to show that all the angles are corresponding to the angles in the other triangle, and you have all three sides corresponding to the other three sides of the other triangle. So what we have right now, let's look angle-wise. We have this angle is congruent to this one. This one is congruent to that one. What angle do we not have congruent? What set? D and B. So I'm going to say angle D is congruent to angle B. How do I know that? How can I say that?
Because the third angle.
Third angle theorem, right? We have these two. The third one's just a given. So we can just say third angle theorem. If you're given two sets of corresponding angles in a triangle, you have the third set automatic. Okay. We were given that AD corresponds with CB, BC corresponds with AB. What is the third side to the triangle? AC is corresponding to AC, right? Is that possible for AC to be congruent to itself? Sure thing. Why is AC congruent to AC? What property tells me that? Joey, when you look at yourself in the mirror, that's Joey. I'm Joey. He's Joey. We're both Joey because the reflection or the reflexive property. The reflection kind of reminds you of it. Reflexive property. Okay, the reflexive property states that it can be congruent to itself. Anything is congruent to itself. It doesn't matter whether it's a point, a line, an angle. Yes, sir.
Why is there even a reflexive property? Isn't that just given?
Isn't that just obvious? Yes. But if we are trying to prove this triangle congruent, that's the only way we can do it. We have to show the third side is congruent to the third side. And since it's a shared side, that's why that reflexive property is important. We have to be able to make that statement. We can't just say, because it's obvious. There has to be a property stating it, okay? And we all see it, it's obvious, but that's the property, all right? Can't just say it, you gotta say why. Now, we're done because we have three sides that are corresponding and three angles that are corresponding, so we can just write our triangle ACD is congruent to triangle CAB. Definition of congruent figures. Okay. Right? Not too crazy of a proof. You really only had to write two statements. Right. Our last slide is kind of an obvious slide, but we'll give it up anyway. It's the reflexive, symmetric, and transitive property with congruent figures. Same properties from chapter 1. But now we're just including figures. Triangles. They're saying triangles. Would it work for quadrilaterals also? Yes. Every figure. We're just saying triangles. Okay? Now, you have a worksheet you're going to work on. And then we will do 4-3 tomorrow. And then we'll be ready for a quiz.